Okay, so today we're talking about the challenge problem for the chapter 10. It's talking about the quadratic equations. So the first question is the C has 20 pieces of the cherry gum and 30 pieces of the grape gum. Let's see, cherry and the grape gum. I have 20 pieces, I have 30 pieces. Okay, so some of the pieces are incomplete packs, other loose, and each complete pack has exact X piece of the gums. If child lose one pack of the cherry gums, okay, if she lose one pack of the cherry gums, then the ratio of the number of the piece of the cherry gum he has to the number of the grape gum will exactly, okay, over 30 will be exactly the same as if instead find 5 packs of the grape gum. Okay, now we can solve this equation, use the cross product. So let's expanding. Okay, so you can see here's the 600. There is easy way to solve it. I will tell you later. Okay, let me finish it first. Okay. So this I want to talk about it. Okay, so we have A over B equals C over D. Okay, so basically the conclusion is we can do in any linear combinations. So A over B equals C over D, then will equal to any combinations. Okay, let's see, alpha times A plus beta times B over alpha times B means C plus the beta times D. Okay, so how we can do this, prove this? Okay, let's do A over B equals C over D equals T, right? So the alpha times A is times T times B, right? And plus beta times C is times T times D, right? Over alpha times B plus beta times D, right? So equals T, then alpha times B plus the beta times D divided by alpha times B plus the beta times D, right? So you can see it's still T, right? So they are equal. So that's why, see, I use this one minus this one, right? I use this one minus this one, right? So basically it's this one times 1, this one times negative 1. So what we have, this one times minus that one is x, this one minus this one is 5x, is 1 over 5. So instead of solving this quadratic, it's a linear equation, right? So then we become easy. It's 100 minus 5x equal to 30. Then we can solve is x equals is 12. Okay. 5, 60, yeah, 70 is 14. Okay. Okay. So Luan and Bobby took the same algebra test. Problem 5 asked them to find the solutions to quadratic equation, and Luan misreading the constant term, and she could have found the roots were -4 and 7. Okay, so the roots is -4 and 7. By reading C is wrong. Okay, C is, we're assuming the equation looks like this. Okay, so for Lu and C is wrong, right? So Bob misreading the linear term, okay, and the correct find the roots is B. Okay, find the roots. The linear term is wrong, so B is wrong. Okay, now let's expanding this one. Okay, so from this one we have the x squared minus 3x minus the 28 equals 0. This one is the x squared minus 6x minus 40 is 0, right? So for Luancy is wrong, this one is right, this one is right, check. For the Bob, B is wrong, this one is right, and this one is right. So now the right quadratic equation is x squared minus 3x minus 40 is equal to 0. Let's do the cross product for factorization. It's xx and negative 8 and 5. So now we have the x minus 8, x plus 5 is equal to 0. So the true roots x1 is 8, x2 is negative 5. Next. So suppose the x squared plus 7bx plus 10b squared equals 0. Solve for the b. Okay, let's see. So let's do the cross product. 1 x, this x term. Then how about this one is 5b and 2b, right? So now we have the x plus the 5b and the x plus the 2b equals 0. So we can solve the x in terms of the b. So x1 equals negative 5b, x2 equals negative 2b. Then find b such that x equals 0, 25 is the solution of the equation. Okay, so there are two possibilities. Okay, the first choice is 25 equal negative 5b. The second possibility is 25 equals negative 2b. For the first one, b is negative 5. For the second one, is b is equal to negative 2. 25 over 2. Okay, so this is the answer. Okay, sorry about it. Box. Next. So find all solutions to equation of this. Okay, the first. Let's do x plus 7 equals 13 minus x. So what we need is, we know this one should be greater than 0, right? So we need this one greater equal to negative 7. And the second thing is, this one is positive, greater equal than 0. This one need to be greater equal than 0. So 13 minus x greater equal than 0. That means x less equal than 13. Okay. This is the first step. Then we can try to take off the root, right? Then we can do the square. Okay, so we can do the this one is the -9. So we have the x minus 18, then x minus 9 is equal to 0. So x1 is 18, x2 equals 9. But don't forget, we need to check the condition, okay? Both of them greater or equal than -7. We need the x less than 13, so this one is wrong. So only solution is next. So find the roots for this equation, okay? So let's see. If you take a look at the term, okay, the first is we can combine, right? We can use the common factors to simplify it. Let's do it. So the 9x plus 1, okay, we can combine this term and this term, right? This one is 19x minus 2 and plus the 2x minus 1, right, times 4 and 2x plus 1 equals 0. So this one is the difference of the square is the 4x squared minus 1 plus, and this one we can expand it. It's 187x squared, then minus 18, then plus x minus 2, then plus this one equals 0. Okay, so then it will equals this 171. So after that you have the 187x squared plus x minus 2 is minus 6 equals 0. So this one you can see here, that's 11, right? 11 times 17 plus x minus 6 equals 0. So let's do this. And I think maybe 3 and 2 here, right? It's negative, so it's positive, so it's this, right? So this is negative 33 plus 32, negative 33 plus the 34 is equal to plus 1. Okay, so that's the coefficients of the x. So now we have the 11x plus 2 and 17x minus 3 equals 0. So x1 equals the 3 over 17, x2 equals negative 2 over 11. Okay. Next. So we note that this one does not equal to this one, okay? So for a plus b of the cube, right? So basically it's the a to the power of 3, right? B to the power of 0 plus something a to the power of 2, b to the power of 1 plus a to the power of the 1, b to the power of 2 plus a to the power of 0, b to the power of 3, right? For the coefficients here, okay, is Pascal triangle 1 is a plus b of the 0, 1, 1 is the coefficients a plus b of the 1, 1, 2, 1 is the a plus b coefficients to the 2, 1, 3, 3, 1 is a plus b to the cube. So that's why you can see it's 1, 3, 3, 1. Okay, this one does not equal, right? So 2 plus x the cube is equal to 8 plus the 3 times 4 times the x plus the 3 times 2 times x squared plus x cubed, so it doesn't equal to the 8 plus the x cubed. Okay, next. So which compare, right? Okay, so we know we need to compare this one versus the 2 root minus 2, right? So let's do the equivalent divide by 2 on both sides. So 1 over square root 2 root 3 minus 1. Then equivalently, because both are greater than 0, right, we can just do a square. So half, and the square of this is the 4 minus 2 root 3. And also we can do the take out half here, and plus the we compare, take out half here, right? Now the next step is equals the 2 7. Now the next is to compare this, square it. So 3 times 4 is 12. This is 4 over the 49, and so this one is bigger. So that's why this one is larger. Okay, next. Consider this one. Okay, let's see. What's the value of x that this product equals 0? A is very simple. X1 equal 1, x2 equal -2, and x3 equal 5. B. Find the sum of the product of the value you found in the. Okay, so 1 minus 2 plus 5 is to the 6 is 4, and the 1 times -2 times 5 is the -10. Then C, expanding the product. Okay, so let's I can directly write, okay, x cube minus 4x square, the plus 10, and what is the x? Let me see. So -10x and -2 and +5, right? So it's the -7x. Okay, so before we proceed forward, okay, I want to tell you this is the Vaeta theorem. Okay, let me talk about the general form. So suppose we have a polynomial equation, okay? Let's see, the px is equal to, I use the cube for example, okay? Let's see, the ax cube plus the bx squared plus the cx plus the d equals 0, okay? If this cube, if there exists solutions, so far we learn real, okay? Basically, it's also work for the complex, okay? Let's talk about that later. So so basically we can write this one as the ax minus the p x minus rq x minus r equals 0, right? So the pqr are the roots. Okay, so Vaeta theorem tells you what's the roots relationship with the coefficient, okay? So the p plus q plus r is the sum of roots, okay? The sum of roots is equal to, or we can always like write a sigma of the p means the roots, just sum them together, okay? So it's equal to the negative b over a. Okay, so the first term is negative, and the next we always write like pq. Okay, this means the rotation, the cyclic rotation of the product of the two roots. Okay, so it means p times q plus q times r plus r times p. Okay, any permutation of the pq, okay, will equal to, this is negative first, that's the sum of the roots, right? That's the, take the coefficients to the x squared. The next is positive, okay, is equal to c over a. Now the pqr, right, is pqr is equal to the negative d over a. Okay, so this is called the Vaeta theorem. This is very powerful theorem and very useful for solving a lot of the quadratic problems, or even the polynomial problems in the mathematic test. Okay. So now I tell you the relationship, right? Now we find the b, so we know there is a relationship, right? So if we can want to expand in this, so that's the d, see? If we want to expand in the term of the x minus p, x minus q, and x minus r, right? If p, q, r is the root, right? What you know is x squared, right? And the p plus q plus r, right, is negative of the coefficients, right? So the coefficients of the x squared is negative p times q times r, right? Then the product is the positive, right? pq plus qr plus rp of the x, right? And the negative final one is the negative of the product together, right? pqr equals 0. Okay, so you can also see from here how you can get the x cubed, right? So you have to take x, that's 1x cubed, right? How you can get the x squared? You have to take 2x and one of the coefficients, right? So that's why it's negative r, negative q, negative p. Okay, how you get the x? If you want to get the x, you can pick 1x from one bracket and the two constant from the other bracket, right? So this one gives the qr, and this will take x, is the pq, you take x here, they give you pr, okay? That's all here. How you get the constant is take the negative p, negative q, negative r, that's this one, okay? So you can also apply this one to the polynomial with the power of n, okay?